Tonight's speaker is Lou Shrinkle, who has been playing with batteries for a long time. And he's going to be talking about one of the projects he's been most passionate about, and that is modular swapping of batteries. So I will turn it over to Lou.
Hello, everyone. Yeah, I'm San Diego native. I went to UCSD, graduate in physics, and I worked in the hard disk drive industry. That's where I spent most of my time, and then got most of my patents there and so forth. Then after that, around 2008, I started working on electric vehicle batteries as a consultant to a company called ATL, Amperex Technology Limited in China. Then became CATL. I think CATL right now is got to be one of the biggest battery companies in the world. And but I was working with them on their early BMS designs and battery testing and so forth. And I've since retired. I still mess with batteries, and you can see the picture of my pride and joy. I have 4 solar panels and a shed full of batteries at home that I get all my transportation energy from. So I'm completely off grid with my car and my electric bikes. So we have the 4 refueling methods that you're familiar with. Level 1, and level 1, a lot of people say is worthless. I actually do use level 1. I think some people still do if you have a lot of time, charge your car overnight, that sort of thing. And if level 2 is not available. Level 2 is the most common one, and for home charging. But I think that a lot of people don't realize that around 50% of the drivers in the US have no access to a garage, 240 volts. So home charging is not, they're living in an apartment. Home charging is not necessarily accessible to them. So they have to, if they have an electric car, they have to look for a quick charge method. So they go out and they DC fast charge. And we'll talk a little bit more about the DC fast charge problems in a bit. And then the last thing I have there is everybody remembers Tesla battery swap. There's the full pack battery swap. And right now, a lot of you guys might know that NIO is doing this in China at a fairly good clip. There's, I don't know, somewhere around 1,000 swap stations in China for the NIO cars. And, China has the problem also that I mentioned 50% drivers in the US don't have access to level 2. In China, that's a lot worse, as you can imagine. The number is kind of more around 80% of drivers in China don't have a 240 volt outlet in a garage they can charge their cars up in. So they either go to a fast charge station or they get a NIO and do the full swap. The problem with the full swap that I thought about a long time ago when I was thinking about this whole battery swap process, and Better Place was around doing their thing, is that the battery is so individual to each car that it would be very difficult coming up with a one size fits all on a full pack swap. So each car is going to have a stock of its own specific batteries at the swap station. I just didn't think that was a good idea. Going forth to looking at DC fast charge, a lot of people that do home charging are happy with fast charge on long trips. It's a half an hour to an hour stop, and that works out. But I'm thinking here about the drivers that cannot do home charging. They are, for them, I would contend that the DC fast charge is still too slow. So we're at 20 to 30 minutes saying, it says there. I looked at the Porsche Taycan is somewhere around 18 minutes for a 10% to 80% charge. And with what I can see with battery chemistry and cabling and cooling and temperature and all that good stuff, I see that there's somewhat of about around a 15-minute practical limit for any DC fast charge. I know that you can see little news blurbs here and there saying battery fast charges in 5 minutes with this new chemistry. Well, that is not looking at the whole picture. I mean, I don't really, and you might be able to get 5 minutes on a single cell in a lab under ideal conditions, but to put that in a pack, I do see that there's some minimum that we're going to have to live with. And the degradation is still there. I mean, batteries do degrade with fast charging, and that graph shows, this graph showing fast charging 1 to 3 times a month, or greater than 3 times a month, or never DC fast charging. And there is clearly a difference. And I know they're working on chemistries to get this better, but right now, if you did fast charge 3 times a month or more, which very few people do, but if you lived in an apartment, you probably would, then your degradation is going to be substantial. I mean, we're looking at something like a 20% degradation in 10 years. I think that no one wants to lose 60 miles out of their range, and even though the car's 10 years old. And one thing pretty, we were talking about that Tesla pack teardown. One thing pretty important to me, given that a long time ago I looked at, at least how much lithium there is in the world, and it turns out there's quite a bit, but not as much as people would think. There right now, of known lithium reserves, there's a finite amount, and actually, if everybody in the world was driving an electric car, we'd be stressing that limit. So we're going to have to recycle batteries, and for some of the metals, including the lithium. And with the large pack, I see that the recycling job is really labor intensive. It requires the manual removal of the large pack. It requires a manual teardown. And since when you have the large packs, there'll be so many different varieties that it's going to be tough to automate that. So actually, these are pictures that Bob came up with, kind of shows the concept somewhat. Either do we fill a big tank, or do we swap a big pack, or do we break it up and use small little tanks or little battery modules? And so when I came up with this idea sometime around 2011, I thought that we'd try to break this up into somewhere around 16, 12 to 20 smaller modules that, you could even lift up manually. And that to me gave the vehicle designer more latitude to make a truck or a small car, or do whatever they want, place the batteries in any way they want, but it gave them more latitude in the vehicle design. That was the idea. And so there were some difficult challenges with the whole concept of taking and breaking the pack up into 16 small modules. You have all these things like, one of these modules been out for 3 years and is older, and you got some new ones and you're mixing them together. and there were some technical challenges to solve, which I was able to, and I got issued 2 patents on the technology I came up with. I worked with UCSD, a group there, for a number of years. We graduated a couple PhD students and had a number of senior projects on this, and we built the car. We did swap, and we also worked on the actual technology that's in the patent. And then a startup company in the Bay Area called Ample Incorporated. I don't know if anybody's heard of Ample, but they got a hold of me. They were just starting, and the guy wanted to license the patents. So I kind of got involved with them and helped them get started. I do not work with them right now. I'm an advisor, but I stay arm's length. Yeah, this is the animation of we did some time ago on. Obviously, it's a very quick animation we did just to show the concept of one way that this could be done. We're removing the batteries out of the car, and then out of the robot, you would replace in this case, 18 modules in the car. Now, this could be done through the side of the car, underneath the doors, through the front of the car, or the way Ample is doing this is they're coming in through the bottom of the car, kind of like Tesla did with their full pack swap. Probably because that's easy, because they can do that without screwing up the body of the car and having to retool all that. And you know, the idea, my idea was that this could also be done manually. So, you know, you could do it yourself. You could do your AAA truck could come and change out 3 or 4 of them, and you'd be on your way. You know, or you can carry your own range extension with you. But right now, Ample is doing this strictly through robots and machinery. So it's only right now it's only a machine load through the bottom of the car. Some of the advantages, and you guys probably might know a number of these, but I'm hoping that I've found a few that might, you know, be a surprise. The big one, the big advantage to modular battery swap is that, and to some people, they don't think this is an advantage, they think it's a negative, but you don't own your battery. This thing would be set up as a subscription model, and the entry price to buying an electric car would be somewhere around $10,000 less. And I think that's one of the reasons why the Chinese are looking at swap, because they want to sell these cars to people who really can't afford, you know, the higher end, you know, Teslas and so forth. So the vehicle cost is reduced. You don't buy the battery with the car. The subscription model is there's now you have a third party that owns the batteries, which in this case I think can be an advantage, because this third party will be they will have the control over recycling. They'll have control over when a module gets taken out of service, and they have control over how it's charged up. And ideally here, you would charge this at a place where electricity is dirt cheap. And we'll talk about that in a bit. Now, with this swap pack, you still will be able to do level 2 home charging. You still could do DC fast charging on this, but there would be like not a point of doing that necessarily. It may be that that's the only way you can charge it. You could still do that, but in the case of these modules, there may not be the kind of cooling that you need for DC fast charging. You'll have there'll be enough cooling for operation and level 2 charging, but DC fast charging is by far the heaviest stress on a battery pack. And that's why there's a lot of coolant and I think that's why Tesla uses all that goop in the pack. Well, swap stations could be easily set up. You don't have an underground tank. You don't have this, you don't have to hook to utilities with a high power, you're not going to be drawing 2 megawatts with these swap stations. The thought is that the batteries would be charged at the electricity generators. So you would actually truck the modules from the generation station to the swap stations. That would be the lowest cost method, because then you're buying your electricity wholesale at 5 cents a kilowatt hour or less. No user maintenance, there's no added fluids or anything to do this. It's and no degradation, because these batteries are charged at a slow rate. They're not charged at the fast rate. So the degradation is whatever the nominal degradation is for a low charge rate. And recall is not a big issue here, because the battery is, to pull the battery out of your car is trivial. It's done all the time. The other big deal with this is that the range of your car should improve as the battery module technology improves. So if you're getting 20-mile modules and they all of a sudden jump up to 30-mile modules, your range is going to improve that much, 3 halves. So you will participate with your car that you own today, you will participate in technology improvements. This next one is debatable, not because now you're not charging at home, so much less fire risk. Fires typically happen in batteries while you're charging them. Not always, but most of the time. Now, fire risk is pretty low anyways, but you guys probably do know that there are a lot of people that are staying away from electric cars because they don't want to buy a car that burns up. Well, if that's a concern, have the batteries charged somewhere else, and then you have a lot less of that worry. It maybe might help some paranoid prospective EV buyers. Okay, system advantages. Again, I was talking about recharging the modules at the cheapest rates. This is where you get the low we'll talk about costs in a bit, but this is where you will get the lowest operational costs of the car, is by getting your electricity at a wholesale rate. It's pretty clear that when we get a lot of solar farms or wind farms, that their energy is transient. It's not going to be there 100% of the time. It's not going to be, there's going to be times when they generate way more than they need to. Well, ideally, if you're charging the modules there, you could charge them up at those times when the wind is blowing the most or when the sun is shining the most, and they can't, that electricity is excess, and you can get that at very low costs. Ubiquitous across multiple uses. Well, this is one of my favorite things about the module approach. Now we can take these modules and look at them as 2-gallon gas cans or whatever. They're just portable energy sources. We can use them in cars, of course, but motorcycles, ATVs, boats, semi-trucks even, you just got to use more of them. Power walls, Something that I would like to see is generators that don't make a lot of noise and don't smell. And then just lawnmowers, tractors, any place where a gas engine is used today, you should be able to replace that with an electric motor with modular power. Recycling, that's a big deal to me. Like I say, I think, you know, we need to do recycling in the future. It's kind of a must. And I believe that these modules could be, once they're standardized in their design, could be designed for recycling so that you can automate the recycling line. The module owners, the guys that are leasing these things to you, would have an incentive to recycle these modules. Okay, then economies of scale. Now we have a standard. If we have a standard, then I contend that the cost will even dive lower, because now you have something that any company is going to have predictability about. It has to fit this standard. It's like making a 9-volt battery. Everybody knows what a 9-volt battery looks like, and the companies that can make those the cheapest and the highest quality are going to be the winners. It'll be the same with these modules, and the competition will drive the price down, and will actually drive the quality up. The quality of these modules are inherently measurable. There are algorithms that you can tell how old the module is. You can tell what its state of health, and its impedance, and you can measure these things and get a very good idea of what the quality of the module is. And indeed, you could probably even get on your cell phone and look at the next swap station and look at the general quality of the modules sitting in that swap station with a phone app. The cost. So this is a wild ass guess on the cost. This does not assume any repair costs, or it does not assume any maintenance costs. Those are out of this number. So tires and, you know, breakage, brakes, anything like that's not in here. But operating costs at 1,000 miles per month. Gas was assumed to be around $4 a gallon, and DC fast charge 35 cents a kilowatt hour. And the swap, I'm assuming I'm getting the electricity at 5 cents a kilowatt hour. There's depreciation in there also, so the swap comes out quite significantly cheaper. That number will obviously depend on what kind of profit. There is some profit built into that, but so that number is based on a 15% profit, something like that. That number could go up, obviously, but it has room to go up. Total cost of ownership for 20 years. I don't know if anybody owns a car for 20 years, but electric cars should last that long. And because of the operating costs being so low, and because you do not buy the battery with the car, so you do not assume the depreciation of the battery and the initial cost. The swap is the lowest cost, total cost of ownership. Swap wins. Number one hurdle, and this is something I fought from day one, and EV manufacturers do not want to standardize. Now, I'm hearing some noise that is changing. There's companies in China. I don't know if you guys are familiar with CATL's chocolate blocks. They make a modular scheme, not exactly like this, but they put 3 modules in a car, and they're getting some of the car manufacturers there, probably due to pressure from the state, to standardize to use those CATL batteries.
Hey, Lou, Tom
Yeah.
has a question.
Sure.
Go ahead, Tom.
Yeah, I was gonna wait until he wrapped it up.
Well, you guys can like interrupt anytime. It's fine, yeah.
Okay, so I'll just shoot one of my first bits of curiosity out there. Is if are any of these are any of the other manufacturers besides Neo taking this idea on? And what is the percentage of saturation that Neo has in China in the overall EV marketplace?
I don't know. I don't think Neo is as big as BYD or Xpeng, but I think they're not small either. So they got a fair amount of their percentage is decent. But there's a company called Geely, Geely, in China that's also doing the swap of the full battery pack. I don't know who CATL is. CATL just announced their modular blocks, their 3-block scheme. I don't know who they're working with. Ample in the Bay Area, and they are working with, they tell me, and I know who the companies are, but I'm sworn to secrecy. They tell me they're working with 5 OEMs right now to implement this into fleet cars.
Okay, well,
Yeah,
so
but-
nobody, as far as you know, named manufacturers in North America or Europe are going ahead with this?
No, this is fairly new. I mean, I have no idea where it's going to go. I mean, to tell you the truth. But like I say, Ample is working with 5 OEMs. They're putting this in their car. There's a couple of the OEMs that are actually building the car to fit. They're actually doing the tooling and doing the manufacturing of the car so it accepts. Then Ample also retrofits cars to accept the batteries. That is only for fleet vehicles. It's only Ample has got to deal with Uber and a few other fleet like Uber-like companies to convert their fleets. Obviously, the fleet has the problem that they maybe have 100 cars sitting in a lot, and they got to charge them up fast. They can't live with downtime. So they have the problem where they need a very fast. They can't put 100 fast chargers in. So they have a real issue with keeping their cars online if they're going to go all electric. And so they're looking at this as a solution. And that's where Ample is focusing on. They're not focusing yet on general transportation. So in terms of general transportation in North America, Europe, nothing, I don't think. I think Neo might have something in Europe, but it's mainly in China right now.
Thanks.
All right. But the reluctance, I understand it. A company like Ford or GM, GM is like going around saying we're gonna own this thing because we got the best battery in the world. We got this Ultium battery. They're going to be hard pressed to give that sort of thing up, and that's also part of their profit structure in their car. But just because they don't like the idea doesn't make it a bad idea. And well, I would say this. I would say that standardization benefits the consumer, not always the manufacturer in general. So this is the current state of where we are, and you kind of are asking that. This shows an Ample charging station. They make this cute little cover thing, so if it's raining, I guess you don't have to get wet. You can see that there's some method of they have some method of raising the car and then going in through some robots. You don't have to dig something out. It's all done above ground, and these these stations are portable, so they can set them up in hours, they tell me, in a parking lot, and then take it and move it somewhere else the next day. To the right, you can see the picture of a couple of their modules that they build. That I was involved in the early design of these, but say they seem to be on their own, and I don't want to work that hard, so they're on their own. Anyways, that's Ample is pretty, it's a serious deal. For a long time, I mean, they were in stealth mode and I didn't know what was going on. I mean, I was working on problems and stuff, but in the last few years, they've raised over $280 million. So they're funded pretty well. And right now, their private valuation is, I guess, what they call a unicorn company. They're valued over $1 billion. So there's some money that believes in them. I think I mentioned that Ample is working with 5 OEMs today, 10 different model cars, they tell me. They have people that go work with politicians, policymakers on, trying to convince them that this is a valid form of refueling a electric vehicle. Personally, I don't know how it's going to happen. It may be a combination. There may be some people that, there may be some manufacturers that go this route, and Tesla and GM just keep making their own batteries. And so the consumer may ultimately have a choice of which way they want to go, and they're going to buy what works for them. I don't think there needs to be a one-size-fits-all charging scheme. I think that we can coexist with I use fast chargers. I think they're great, and I use home charging. So it's I think that we Ample is just looking at being recognized as a potential. And so when states and cities and so forth make their policies on charging and infrastructure, that they want to be in the mix. So they have a bunch of people that do outreach, and they work with Uber and Electric Drives something. They work with a number of companies they partnered with to launch this stuff. So it's still really in its beta test. But they tell me that next month they're going to make 30,000 modules. So they're getting somewhat serious about numbers. So they are getting into that production hell that Elon talks about. So that's what Ample is doing, and I'm putting a lot of my hopes in Ample to carry this to fruition. But what can we do? I mean, I think that to just educate ourselves on this technology and understand the options, invest wisely in companies that are doing the right thing, and not in ones that are doing the wrong thing. And I did write, as some of you know, I wrote a book on this and just published it last February. I thought it would be nice to have a book that dived into the details a lot more than I'm doing in this talk. And so if you read the book, you'll hear a lot of the same stuff, but you'll, like on the numbers and all, you'll see what all my assumptions are, and a lot more detail on things. And I have a website, modularswap.com, and Ample's got one, ample.com. I encourage everybody to go to those and just educate themselves on what we're doing. If we're, this may happen, and it might be good to know about it. Pass the knowledge on to others and do whatever, influence we can. That's kind of what I think your mission is anyways, is to educate and advocate for electric cars in general, not caring what charging's methodology you use, but this might be part of the discussion with some of your people. This is
Kurt?
kind of what I think to me was like the most important slide of all of them. When I first thought of battery swap, I did this thought experiment, and because physicists do thought experiments. But the basic deal was, we know that batteries are going to get way smaller and lighter. It may not seem like that today, but they already have, to tell you the truth. They're probably a factor of 2 better than when we started building electric cars. But they are working on some battery chemistries, such as lithium sulfur and lithium air. These things are still pie in the sky a bit, but my experience with technology tells me that if there's a buck to be made, they will solve it. They will go up against the laws of physics as far as they can. And so I think that in my mind, there's no doubt that someday we will have a 300-mile battery that weighs somewhere in the order of 60 to 100 pounds. That's not even the theoretical limit. That's more of a practical limit. That battery, it should be clear to everybody that that battery would be trivial to do a swap on. I mean, if you're talking about roughly six lawnmower batteries. A person could do that manually in less than a minute. But that same battery would heat up even more on a DC fast charge, would even be slower than 15 minutes because the battery is so small, its thermal mass, it just couldn't take the power. So I think that this thought experiment just proved to me that the swap technology will scale much better than what we're doing today as we shrink the battery and increase the energy density. Some people say we'll never get there. I don't buy that. I think we're going to get there. Maybe it won't quite make 100 pounds, but it's going to get small and much lighter. Curious to hear what you guys think about that, because that really is the thing that's been driving me on this since day one, this whole argument. And I've not, besides the fact that I think it was just a better idea. And this is a picture of the book that I wrote. It's available on Amazon. I didn't do this to make money. I did this to get the information out. So I'm a member of San Diego 350 climate change group. So all profits go to them. And my website is there, modularswap.com. That's it. Thank you.
All right, Kurt has a question.
Sure.
Hey, can you hear me okay?
Yes.
Yeah.
Hey, yeah, so a lot of parallel thinking, a lot of other people have thought about similar things. One of the things I was discussing with some folks was batteries and trailers so that you can make road trips. So you want to drive to San Francisco, you have a very lightweight frame you pull behind the car. So let's say somebody retrofitted this to an existing Leaf. You'd have to work out the wiring because right now it's not easy to feed battery power into a Leaf. But if somebody worked out the software, you'd have a very lightweight frame where you'd pull batteries behind you and there'd be places along the way to stop and swap out the trailer. You'd have to do the math, but you know, maybe it's every 200 miles, there's a way station along I-5. And every 200 miles you stop, you unhook the trailer you hook up another trailer and you continue on. The other thing for that was for Uber drivers, where they'd pull a lightweight trailer and the bottom half of the trailer would be batteries The top half of the trailer would be cargo. So you pick up 3 or 4 people in Oceanside. They put all their suitcases in the top of the trailer. You take them to the airport. They get out, they take their suitcases, and then you go to a station somewhere where you swap out your empty trailer for one with fresh batteries, and then you make another airport run. So instead of stopping, as I think the Bolt drivers now have to stop for about half an hour, 45 minutes between airport runs. Instead of stopping for 45 minutes, they just go somewhere within a couple miles of the airport, swap out their old trailer, get a new trailer. And in the course of an 8-hour day, they get more airport runs in. It would increase their revenue, and part of that revenue would be shared with the trailer vendor. And then when you start thinking about trailers, you can also have other forms of cargo. Maybe a drug company has pharmaceuticals they need to take from a distribution point out to, let's say, a drugstore in Ramona. Well, they just pull the trailer up there, drop it off, pick up another one that's been charged. And you don't have to worry about physically pulling batteries in and out of the cars. The car
Right.
can run so many miles on its internal battery, whatever that might be. And then the trailer gives you additional utility.
Right. No, that trailer gives you more space for batteries, and that's probably a good thing. Yeah. I did not think about trailers in all this, I mean, obviously I was confined myself to thinking about how do we do this in a, standard car without a trailer, sans trailer. So, but trailer would give you that, yeah, you'd have to cable it up and it would be another energy source. Exactly.
The weight, obviously, it would be self-defeating to a certain extent, where the weight of the trailer would reduce your range, but
Right.
Maybe it reduces your range by 30 miles, but it's adding 200 miles. So
Right,
there'd be a net gain.
right.
And maybe there'd be a way to say, I'm going to use the juice from the trailer. I'm going to maintain the juice that's in the car, or maybe the trailer is actually charging the car. So the car starts off with a 50% load while it's driving, the trailer's powering it, but it's also charging the battery, so that at a certain point, you don't need the trailer anymore. The other thing we were laughing about is a little bit like the first stage, second stage on a rocket.
Yeah.
Maybe you take the trailer from here to, say, like Santa Clarita, and
Yeah.
you drop it off, and then
Drop
you
it.
continue.
Yeah.
You continue on, and you go to Fresno, and the trailer's charging in Santa Clarita, and on the way back, you stop and you pick up your trailer again. It take you the rest of the way home. So a lot of creative things you could do. We also were joking about one car pulling another. You actually use an empty car to pull a full car, and maybe the empty car is full of passengers or whatever. Now you're starting to get into issues with, I know buses pull, second buses, but you
Yeah.
get into issues now where maybe the Department of Transportation wouldn't want passengers riding in a trailer. Probably not, but all kinds of ideas there.
Yeah.
When you think about the
Yeah.
modules that you can move around.
Yeah. No, I mean, I agree. Trailers, I've heard the concept, and yeah, it makes sense. I mean, obviously Ample, I think, is working on this. They're taking the long view on this. They're not looking at having something that's going to be out in 3 or 4 years from now. I think they're looking at 10 years from now. They're really going for the long view, and as the battery density shrinks, their method is going to make more and more sense. That's kind of what I was trying to say. But yeah, but trailer would be something that could, yeah, it would work for sure.
A lot of ways that we could increase the utility of electric automobiles. The other thing that's also coming up are these electric drones, which someday, we're not too far away. Let's say an electric drone could take off from the Torrey Pines glider port, and where it probably could get licensed, but they could get approval from air traffic control to go in and out of there. And from there, they could make a run up to Oceanside or to Ramona or whatever, bring people into the glider port, at which point they could pick up the trolley and continue their trip. They probably don't want drones flying around Miramar or Lindbergh, but if they could get the glider port, I think, is outside the Class B airspace.
You're
But
talking
the point
about
is,
pretty big drones, huh? Those are.
Well, they
Big
might be
ones.
they would be autonomous, so there's no pilot. So you
Yeah.
only have 1 or 2 or 3 passengers. But my point was the batteries that you use in the drone could also be used for the vehicles, the cars and
Sure.
or trucks. You could
Sure.
also have autonomous trucks running cargo runs, maybe at night when the freeways aren't so busy.
Mhm.
But once you have that battery technology, it could be car, truck, aircraft, and I don't even know what the railroads are thinking about electric railroad vehicles. But
Mm.
you know, once you get the battery and the locomotion, they can have rubber wheels, wings, rotors,
Yeah.
or rail wheels.
Yeah, I think that, I mean, yeah, I think that even putting these batteries in semi trucks makes sense, because now obviously you're gonna put quite a few more in. You're gonna, maybe you have 50 modules in a semi truck, but so what? It's all done by a machine and it's gonna be relatively quick. Why not use the same battery in a semi truck that you use in a car?
Yeah.
Drive the economies of scale up and the price down.
Yeah, well, obviously Elon's looking at the semi truck, and I think what they're looking at are truck trains, where you might have 50 trucks in Victorville that caravan to Las Vegas or Oklahoma or whatever. Maybe every 10th truck has a driver, and the other 9 are just following behind the first one using radar. But so you have a driver available in case there's a problem, but you seriously have 10 or 12 vehicles. And again, that would be something you do at night, because you ever been out in the middle of Las Vegas at night, the freeways are empty. So do all your freight at night.
All right.
Yeah,
All right,
thank you.
Tom, you want to go?
Oh, yeah. First of all, Lou, thanks a lot for thinking outside the box there. I think battery swap on modular basis is, in my view, ahead of hydrogen. And I don't see a big uptake on hydrogen.
Uh-huh.
I definitely, in regards to trailers, yes, Jehu and I, we have already done a trailer trip to Lake Havasu. You guys know that us VW people are really kind of crazy about this battery and electric technology, and bring it into our realm of vintage VW buses. And we're definitely interested in the modular aspect. One of the things we're doing at EV West is harvesting these modules out of wrecked Teslas. We've got pallets full of them. And so we're thinking in terms of a box that can be lifted in and out, that has 5 or 6 Tesla modules in it. And we're actually already doing this. We are adding a second box. We've got 120-mile range with one box, and we put that box in and double our range. So this is stuff that we are playing with already. By the way, I just Googled Ample and I signed up for their newsletter. I'd recommend the rest of you guys do the same thing. It's a no bullshit company. I think there's definitely something to what Lou is talking about here. And lastly, I just want to mention that Ron Grossinger just checked in with me and he said there's 2 spots left at the EV Learning Center for Saturday. If anybody wants to sign up, it's $105. We make a small EV and we race them at the end of the class. It's a lot of fun, and the easy way to get into this.
Wow. So Tom, you know Jehu, right?
Jehu is one of my very good friends. Yes.
I love that guy's website. I buy these batteries from him all the time to get these, deals. I actually sent him a note saying, hey, someday I'd like to meet you and buy you a beer. So maybe I can set that up sometime through you.
Yeah, Jehu is buying secondhand batteries, surplus batteries by the container full these days. And a lot of the people that are buying his stuff are doing modular technology. So
Right.
it's
Ah.
not, I would imagine a lot of you guys sitting in today's call, driving your newish EVs are probably shaking your head going like, modular doesn't work for my car. Modular doesn't work for the way I use my vehicle. But I'm here to tell you that modular is alive and well. People are buying these battery packs from Jehu. He's selling them in, I would say, a couple of dozen different form factors. Uh, and modularity comes down to series and parallel and voltage. You can build it in any shape, size, dimension that you need it to be. So it may be decades before we decide on one form factor, but we've already decided on many different form factors, and modularity is happening. That's
Well, the guy, Jehu is an amazing guy. He's the hardest worker I've known. He builds so much stuff.
Yeah.
It's pretty incredible.
All right, Dean.
All right.
Dean.
Hi guys. Thank you, Lou, and thank you everybody on this call involved for this ecosystem. So my question is about your second slide, where you say DC charging will be slower with smaller batteries. So it's kind of a technical question. Is that because the electrodes will be more dense, and so you're dissipating more heat from a smaller area?
Well, that's because the thermal mass of the battery will be less. So if you take a big piece of aluminum and put 1,000 watts into it, it will heat up a certain amount. A smaller piece of aluminum heat sink, 1,000 watts will get it very hot. So you need size and mass to dissipate the heat along with the cooling fluid. It's not just if it's only the cooling fluid won't be able to keep up because the thermal mass will be too small. So it will be, going small does not help the heating problem. And, and to get 300 miles on a fast charge takes so many kilowatt hours. There's no way around that.
I thought that was it's not obvious. It was a very subtle, indirect point, but it really does make the swappable idea more attractive. I had another question.
Yeah.
I had another question about the standardization idea. So what does that look like? For example, let's be specific. If we looked at a NEO module, what would those interfaces look like? And without giving away trade secrets about Ample, just generally speaking, you obviously have a negative and a positive, but what else is going on in a standard that would be more generic all over the world?
There's a negative and positive. There's your main bus. There's a couple interlock connections you need to use for safety. Then outside that, you have a communication cable. So the communication cable is not essential. You could do that wireless. So effectively with each module, you could have two large, contacts, for the positive and negative bus, and then a couple smaller contacts for the interlock, which is the safety feature.
I see. So the interfaces are functionally very manageable. It's more about the form factor and the mechanical fit, which is obviously not trivial, right? On millions,
not trivial at all.
Batteries, right?
No,
right.
Not trivial at all. When you saw my video, you saw that I prognosticated putting some tubes under the car, that the batteries would slip into these tubes. That's my idea. I'm not a mechanical engineer, but the tubes give you the advantage of good stiffness, good, structural, and ability to cool and heat the batteries in the tubes and to control their temperature. along with a nice way to, put them in and out. Ample does a different deal. They have a tray where they mount the modules on a tray, and the trays go, there's 4 trays of 3 modules each that go up into the car. So it's a little different, but I really do believe that as we go to smaller batteries, that we will, I can't predict what the final implementation of this is even going to look like. There's an argument saying, well, if we're gonna get really small batteries, why don't we make 1,000 mile or 2,000 mile cars? And I don't think that that's also a good idea, because I think you're still going to pay significantly per the kilowatt hour. That's not going to be that's not going to scale. So that 1,000 mile battery is going to be quite expensive, and it's going to take forever to charge, of course. I think that I think a lot of people talk about this, and I think that the people at Volkswagen think that a 300 mile battery is the sweet spot. I think there could be many opinions about that, but 300 miles seems to be about a good sweet spot for an electric car.
All right, Susan,
Yeah.
you have a question? And this will be our last question.
Okay, thank you, Lou, very much. Well, and so now I just triggered another question, but I think the sweet spot is more like 400 to 500. That's my personal opinion. And keep in mind, it costs the same amount to charge a 300 mile range battery, 3 times as it is to charge one 900 mile battery once.
Right.
And then plus, if you're doing it 3 different times, you've got your transaction cost of your time, going and whatever, carving that visit, driving to whatever. So anyway, but before you made that comment, what I want to say, besides thank you for the wonderful presentation. It was very interesting.
Oh, good. Thanks.
Just kind of background information, kind of marketing, me, as I was a semi-early adopter, but when I was considering buying my first electric vehicle, part of what sold me was I saw that YouTube comparison between the Tesla swap out battery and the Audi that was being filled up or something with gas. I forget exactly what it was. But so when I actually started pursuing, the purchase with Tesla, I thought that was still in place, because I didn't want to go get no supercharger, and I do live in a condo, so charging at home wasn't at that time possible.
Okay.
So fast forward now through Sempra Energy Power Your Drive, I did get 6 communal electric vehicle charging stations here in my condo complex. So now I don't want to go to no supercharger. I want to just charge at home. So so even though I see the advantages of swap, there's still that transaction cost. I'm very comfortable I love not having to go to the gas station to fill up. So I like what you said about kind of combination, maybe a hybrid approach where you could have kind of a subscription that was only on kind of like when you're traveling, you sign up for a limited subscription when you're traveling, like turn on, turn off, or however. But I can see a real advantage. And then on a final note, with Europe or the European Union finally telling all computer and other device makers that they're going to have the same plug system, whatever it's going to be. I think there's a role, once the technology is further developed, and we kind of see from your standpoint as a background that I lack, science and engineering and all the technology, which are the better performers, and then have hearings, or I don't know, however the laws are made, to where there is some standardization that takes place to simplify things in some of the manufacturers are just going to have to get on board, or what, however that's going to be worked out.
There's going to be a lot of decisions made. Like I told you, you still will be able to charge this swappable car at your home. That's still going to be possible. Now, I gotta confess, the Ample guys don't want people to charge at home. They want them to come in and swap the batteries out. So they're going to fight that. So I think, and I tell them, I say, well, that, you're going to lose a lot of people on that one. So so there's going to be a lot of decisions made, and we have policymakers. I mean, we have people like, we have government people that want to put level 2 chargers everywhere on the freeways, and that just doesn't make any sense. So we have to, I think that is very important that we all get educated and and know at least at some level, the pluses and minuses to all this stuff. And who knows what's going to happen, but I'm hoping that good ideas do win the day, in the end. But yeah, I think that you're right. I think we're going to end up with multiple choices for the consumer, and I'm hoping that home charging will be one of the home and workplace charging will be the dominant source of energy for a car, and that apartment owners and utilities and so forth will make that even easier, so we can get that 50% number of drivers up higher, and more like 80% of the people have access to level 2 charging. And that's where we should go. We should be going that direction. And then we don't need so many DC or swap stations.
Okay, well, and I also want to see kind of like a more getting off the tires and having kind of like a hovercraft like in the Jetsons, so that we don't have to have asphalt covered roads. We can have greenscape and just have pathways that we're flying over it 5 or 10 inches. But that's a little further down the line, right?
Probably I won't see that. I don't think that's going to happen in my lifetime, but who knows? All right.
Live long and prosper.
Yeah.
Thank you.
You're welcome.
All right, well, thank you everyone for showing up this evening. Thank you, Lou, for your wonderful presentation and a lot of in-depth questions.
Good. It was good. Yeah.
Yeah, so
Good
with that,
questions.